Hi, myself S. Lakshmanachari, working as Assistant Professor in the Department of FEC, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to discuss the topic distortion in amplifiers. So, already we have discussed in the previous class, we have discussed the introduction to the amplifier. So, amplifier is an electronic circuit or device which will amplify the given input signal without distorting its shape. So that is an amplifier. So the amplifier will do the amplification. So basically for any amplifier, we are applying a AC signal, alternating signal. So the alternating signal, it consists of three main characteristics that are amplitude, frequency, and phase. So, if you take any signal, it consists of these three characteristics: amplitude, frequency, and phase. So, the amplifier. So, when you apply any input signal to the amplifier, then you will get the amplified version of the given input signal at the output of the amplifier. So, that means the amplifier can able to reproduce the given input signal. So, reproduce means the output signal wave shape should reproduce or same to the applied input signal. So that is a reproduction of the given input signal. So if the output signal shape and input signal shape is not same, then we can say the output signal is distorted. So from the previous video, we learned that the signal amplifier to work correctly, it should require some form of bias, and that bias voltage we are applying at the base of the base terminal of the transistor, so that it amplifies the input signal over its complete or entire cycle. And the Q point or operating point, it will be set at the middle of the load line as possible as. So always the Q point will be located on the center of the load line. So generally we will draw a load line between the collector to emitter voltage and the collector current and the load line. So always the operating point or Q point, it will be middle on the center, middle or center of the load line, so that the amplifier can able to reproduce the given input signal at the output of the amplifier. Otherwise, the signal may get distorted. So if the operating point is located on the center of the load line, then such type of amplifiers are called Class A amplifiers. So in Class A power amplifier, the output current which flows for entire 360 degrees of the given input signal. So such type of amplifiers are called Class A amplifiers. And however, incorrectly biased. So if we not provided correct biasing, then it leads to some distortion. So however, if we incorrectly bias our amplifier circuit and set the Q point at a wrong position. Okay, if we are not providing a correct biasing, or if we place a operating point on the in a wrong position, then it will leads to a distortion. So that means always the Q point will be center on the DC load line. If it is shifted upward or downward, then it leads to the clipping at the output waveform. So that is called the distortion. So if you take any amplifier, generally three types of distortions will occur, that are amplitude distortion. So amplitude distortion or non-linear distortion. Okay. Second one, the frequency distortion. And the third one, phase distortion. So these are the three main distortions occur in general in the amplifier circuits. So we will see what is distortion. So the definition of distortion is the distortion in amplifier, basically the variation of output waveform received at the output of the amplifier with respect to input waveform applied. So that is called the distortion. So distortion means the variation. So the variation of the output waveform. So waveform received at the output. So waveform received at the output with respect to the input wave. So if both the output waveform and input waveform both are same, it means there is no distortion. But if the output waveform is different from the input waveform, then it means the output signal is distorted. And here you can see a single stage common emitter amplifier circuit. So this is a amplifier circuit. So here we are applying a input, a sinusoidal signal, and we can get the amplified signal. So this is an amplified signal. So generally you're supposed to get the waveform like this. But here at the output waveform, there is a clipping takes place here. There is a clipping takes place. So this portion is clipped off. So this is due to the various reasons the output waveform may clip off. So because the temperature variations or incorrect biasing. So due to that various reasons the output waveform may get affected. Okay. So a pure signal always has a single frequency component where the positive and negative cycles are varies equally, varies by equal amount, and if the variation is less than 360 degrees, then the signal may say it is distorted. That is a distortion. So here consider an amplifier. So this is an amplifier. Okay. So for an amplifier, we have applied a input signal, sinusoidal input. Then you can see the output waveform. So if you see the output waveform, we got a output waveform, amplified version of the given input signal. But the shape of the output waveform is not similar to the input waveform because there is a clipping. Takes place at a positive cycle at the peak of the positive peak cycle, and also the clipping takes place at the negative peak of the cycle output waveform. So this is called distortion because there is a variation in the output waveform with respect to the input waveform. So such variation is called distortion because due to many factors the output voltage may get affected. Okay, so because when we talk about an ideal amplifier, so because in real time there is no such ideal amplifier exists because the every amplifier it is having some resistance or due to the temperature variations the amplifier characteristics may change. So due to that the output voltage of the amplifier might change. So that variation is called distortion. So the amplified output must be an exact replica of the input. Okay. So in ideal, the output of the amplifier should similar to the input of the waveform. But in practical, due to these different factors, the output voltage may not similar to the input. So that is called the distortion. And for a distortionless output signal, the DC biasing is at the base or gate terminal. So for distortionless output signal, we should provide a proper DC biasing at the base or gate terminal of the transistor, so that so that it will provide a faithful amplification. Faithful amplification means the output waveform will similar to the input waveform. So these are the different regions for the signal distortion. So there are different regions are there. The first region is due to the incorrect biasing. Incorrect biasing. So due to incorrect biasing, when the signal is not amplified for the entire cycle of the input signal, then distortion occurs. So that is the first reason. So due to incorrect biasing, the signal is not amplified for entire cycle of the input signal. That means the bias, we may provide a poor biasing or over biasing. So due to that, the operating point might change. So if the operating point, see here, so this is a DC load line. So it is drawing between the VC versus IC. Okay, so if the operating point is located on the center, then you will get a faithful amplification. Otherwise, if the operating point is shifted upward or downward, then your output voltage might affect it. So if the operating point is shifted upside, then the positive peak of the output may clip off. Similarly, if the operating point shifted down, then the negative peak of the output waveform might affect it. Okay. So this is the output signal. So if the operating point is shifted upside, then this positive peak will clip off. Similarly, if the operating point is shifted downside, then the negative peak of the output waveform will be clipped off. And the second reason is it also occurs in case when the applied input signal is very large. Even sometimes we provide a proper biasing, then the distortion will occur because of when we are applying a large input signal. That is the second reason. And third reason is the distortion in amplifier sometimes results when amplification is not linear over its complete frequency range. So because of non-linearity, then the output signal may get affected. So these are the three main reasons for distortion to be occur. And the first one is the amplitude distortion. So the amplitude distortion we can also call non-linear distortion. So in practical circuits, the dynamic characteristics of the transistor are not perfectly linear in the active region, because already we discussed it. So no amplifier is ideal. All amplifiers are practical in nature. That means it is having some resistance, or the characteristics of the amplifier may change due to the temperature variations. So because of that, the output voltage may get affected, so that the distortion will occur. Okay. And second one, that due to nonlinearities in the dynamic characteristics, the waveform of the output waveform differs from that of the input signal. And such distortion is called nonlinear or amplitude distortion, because this type of distortion mainly it occurs on the peaks of the output waveform. So that means it may affect on the positive peak or negative peak. So it will affect on the amplitude only. That's why it is called amplitude distortion. And this type of distortion occurs due to the attenuation. So this type of distortion occurs mainly due to the attenuation in the output waveform. So if you see here the output waveform, so there is an attenuation in the positive peak. There is attenuation in the positive peak, and similarly there is an attenuation in the negative peak. So this is the attenuation. Because of that attenuation, your output voltage clipped off at the both positive peak and negative peak. So because of the attenuation or the shift in Q point, and amplification for less than 360 degrees of the input signal, that leads to the amplitude distortion. So these are the main regions. So the main regions are due to the attenuation or shift in the operating point or the amplification for less than 360 degrees of the input signal. So because of attenuation, the positive peak or negative peak gets affected, and due to the shift in operating point also. So if the operating point is a move to upside, then this positive peak will affect, and similarly if the operating point is shifted downside, then this negative peak gets affected. That means the negative peak will be clipped off, and it occurs mainly due to the incorrect biasing. So if we are not provided incorrect biasing, then the operating point will be shifted to upside or downside. So the operating point will be in the center of the load line only if we provide a proper biasing or correct biasing. Then only the faithful amplification takes place in amplifiers. So faithful amplification means the output waveform will, the shape of the output waveform is similar to the shape of the input waveform. So let us understand the distortion by using different cases. The first case. So the case 1 is suppose insufficient biasing is provided. So if the insufficient biasing is provided, the Q point will be shifted down. Q point will be near to the lower half of the load line. So generally the load line, it will be here. For faithful amplification, the operating point, it will be in center. But because of insufficient biasing, this operating point, it is moving to the lower half of the load line. So this is a lower half. So that means this operating point, it is shifting to down, so that the negative peak of the output waveform gets clipped off. So because of that, the negative half of the input is clipped, and we get a distorted signal at the output of the amplifier. So here you can see the figure here. So the green color wave is it is a input waveform. So this one, okay. So this is the input waveform, and the blue color is it is a output signal. So here, if the operating point is located on the center, then you will get the same shape output waveform. So the output waveform shape will be similar to the input waveform. So that is called faithful amplification. But here, insufficient biasing. So due to the poor biasing or insufficient biasing, the operating point is shifted to the lower half of the load line. So that's why, see here. So there is a clipping takes place. At the negative peak. So if the insufficient biasing is provided, then the negative peak of the output waveform gets clipped off. Okay, so this is the first case. So that is a insufficient biasing, and then move to the second case, that is extra biasing. Suppose if we provide a extra biasing to the extra bias potential is provided, then the Q point will be moved to the upper half of the DC load line. So the load line will be like this. Okay, so always the Q point will be on the center of the load line is desirable, but here, due to the extra biasing is provided, this Q point is moving or shifted to the upper half of the load line. So that's why there is a clipping takes place at the positive peak of the output waveform. Okay, so here this is a center of the load line, but here the operating point is shifted from center to here. So because of that, there is a clipping at the positive peak of the output waveform. So here you can observe a clipping. So you supposed to get the output waveform like this. But instead of this, you get only here, this is the waveform you got. Okay, so that's why if you provide a extra biasing, then the positive peak of the output waveform might affect it. And third one, so third case is sometimes even if we provide a proper biasing, because of high input that leads to a output waveform distorted. So even if you provide a proper biasing, because of very high input voltage, then the distortion will take place at the output of the amplifier. So here you can see, so this is a input waveform. So because of the high input waveform, so there is a clipping takes place at the positive peak and negative peak of the output waveform. So see here. So you're supposed to get the waveform like this. So you're supposed to get the waveform with the red color, but you are getting only the shape like this. So that means here there is a clipping at the positive peak and negative peak. So this is due to a very high input. So this is a third case. So total, because of the three regions, we are getting a output distorted waveform. So that is one. The first case is poor biasing. So due to the poor biasing, the negative part of the negative, there is a clipping at the negative peak of the output waveform. And if we provide a extra biasing, then there is a clipping takes place at the positive peak of the output waveform. Similarly, if we provide even if we provide a proper biasing, because of very high input voltage, there is a clipping takes place at both the positive peak and negative peak of the output waveform. And the second one is the frequency distortion. So this type of distortion occurs when the signal components of different frequencies are amplified differently. So previously we have seen the amplitude distortion. So the amplitude distortion, mainly it will affect on the amplitude of the output signal waveform. Here it is a frequency distortion. So the input frequencies will be amplified by different frequencies. So this distortion either due to the presence of reactive elements. So reactive elements like inductor or capacitor, or by the electrode capacitance of the amplifier circuit. So because of this, this frequency distortion may occur. And see here, when the input signal with frequency f, input signal is with frequency f is applied to an amplifier. So we have an amplifier and we have applied a input signal with frequency f. Then the output signal, it consists of some DC components and several harmonics. Okay, so the several harmonics are F, 2F, 3F, 4F, and so on. As a result of this, harmonic distortion occur in output signal. So because of that, there is a harmonic distortion because we have applied a input signal with frequency F. But at the output side, you can see here this green color. So this is called a fundamental frequency. So the alternating signal, it is having a single frequency. So that is a fundamental frequency. But here, along with the fundamental frequency, some other harmonics are generating. That means the output signals with different frequency. So that means the frequency of this harmonic is 2f. That means the time period will be t by 2. If the time period of the fundamental wave is t, then the time period of this harmonic, second harmonic, is t by 2. So the frequency of the second harmonic is 2f, and the frequency of the third harmonic will be like this. Okay, so this is a third harmonic. So the frequency of the third harmonic is 3f, and similarly 4f, 5f. So these are all called the harmonics of the fundamental frequency. So here you can see the input and output signals. So see here. So this is a input signal. This is a input signal, and this is a input signal with harmonic, and you can see the output waveform here. So the output waveform, this one. So you're supposed to get the waveform like this, but this dotted line waveform is a frequency distorted output waveform, because of this harmonics there is a distortion. So then the output waveform will be like this. So this is a dotted line. So this curve is the output waveform. That waveform is called frequency distorted output waveform. Okay, so this is a harmonics. So this is a harmonic. This is called second harmonic. Because this is called second harmonic because the frequency of the fundamental wave is f, and the frequency of the second harmonic is 2f. So like that 3f, 4f, like that different harmonics will be generated. And these harmonics we can remove by using some filters. So there are different types of filters are there. Active filters, passive filters. So by using the active filters, we can eliminate all these harmonics, and finally we can get the original signal. So this is a frequency distortion. And third one is a delay distortion, delay or phase distortion. So phase distortion in an amplifier is also known as a delay distortion. Delay distortion. As the name indicates, when there is a time delay between input and occurrence of the signal at the output. So whenever there is a delay between the output signal or with respect to the input signal, then the type of distortion is called phase distortion or delay distortion. And it is said to be phase distorted signal, and it occurs mainly due to the electrical reactance. Because of when you are using any capacitor or inductor, then this type of phase distortion will occur. And so when different frequency suffers different phase shift, phase distortion takes place. So here you can see the output waveform. So this is a input signal. So this is a output signal, and this is an input signal, an input signal with second harmonic wave. So output. So there is an output signal. So you are supposed to get the output waveform like this. But instead of that wave, you are getting this dotted waveform. So this dotted waveform is said to be phase distorted output waveform. Phase distorted. Because if you see the second harmonic, so if you see the second harmonic, so the second harmonic, it is started with this point. It is started with this point. But actually, it has to starting with the center of this point. It has to starting from this point. But instead that, it is started with this one. So there is a delay. So that type of distortion is called delay distortion. So this second harmonic, it is started with some phase. So this one. Okay. So this type of distortion is called phase distorted signal. So this dotted line is the phase distorted. And the type and amount of distortion that is tolerable or intolerable depends upon the application of the amplifier. So sometimes this type of distortion we can consider, or sometimes we cannot consider. So that depends upon the application of the amplifier. Okay, so in this class we have learned about the different types of distortions. So mainly three types of distortions are occur. So that are the amplitude distortion, second one frequency distortion, and third one phase distortion. So amplitude distortion is called non-linear distortion, and frequency distortion and phase distortion both they come under the category of the linear distortion. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.